Today I will go through the steps and explain how we solve question 13A, B, and C. Take a few seconds to read the question above. The first step in solving any problem is figuring out what type of problem we are dealing with. First off, let's figure out what type of function we are dealing with. The equation is c of t is equal to 5t all over 2 squared plus 7, which is a rational function. Now that we know what kind of function we are dealing with, let's move on to seeing what the topic of the question is. As we can see, the topic is biology, more specifically the concentration of blood in the bloodstream. Now that we have identified the topic of the question and the type of function, let's look at what question A is asking us to find. Question A is asking us to find the average rate of change. We know that AROC is equal to C2 minus C1 all over T2 minus T1. We already know that T1 is equal to 0 and T2 equal to 2. So let's solve for C2 and C1 using our formula C of t is equal to 5t all over t squared plus 7. First, let's solve for C1. Now let's solve for C2. We are now ready to solve for AROC. Now to properly conclude our question, let's include our therefore statement. Now that we are done question A, let's take a look at what question B is asking us to do. Question B is asking us to find the instantaneous rate of change at t is equal to 3. Let's start by adding and subtracting 0.001 to 3. Again, we know that IROC is equal to C2 minus C1 all over T2 minus T1. Now let's solve for C1 and C2 using our formula C of t is equal to 5t all over t squared plus 7. Now that we know all our variables, let's solve for IROC. Now to ensure full marks, let's include our therefore statement. We are close to being done. Only one question to go. So let's take a look at what question C is asking us to do. The first thing it is asking us to do is to graph the C of t function. So let's start off by doing that. Take a look at the graph. This function is a rational function, and therefore we can notice that the concentration is not always increasing or decreasing at a constant rate, causing the curves in the graph. The slope of a function increases as the steepness of the line increases as well, because the rise over run is higher. Let's now do a few calculations to prove our answer. Let's pick two different points at two different levels of steepness throughout the graph and calculate the slope between them. Let's pick the points 0, 0, and 1, 0.625 as our first slope calculations, and 2, 0.909, and 3, 0.938 as our second slope calculations. To calculate the slope, we use the formula m is equal to y2 minus y1 all over x2 minus x1. Let's start by calculating the slope between the points 0, 0 and 1, 0.625. Now let's calculate the slope between 2, 0.909 and 3, 0.938. Now let's compare the slopes. Which one of the two is higher? We can conclude that the slope between the points 0, 0 and 1, 0.625 is much higher. This is because the rise over run is much higher between these points, as shown above. We have now proven that the steeper the line is, the higher the slope, and therefore the highest slope in this graph is right before it starts curving, as shown by the arrow above. Let's conclude this question with our therefore statement. Interested in becoming a doctor or a nurse? These professions solve questions similar to this on a day-to-day basis. I hope this instructional video helped and improved your math skills.